1. E. F. Gautier, 1928. 2. T. Morneau, 1945, Berg-Wartenstein Symposium, 1961. 3. Archipo Reed, 1953. 4. J. Dubeef, 1959. 5. Helbelout, 1952. 6. K. W. Butzer, 1958. 7. S. Hughes A. 1936, pages 19 to 22. 2. Methodology and African Prehistory. Its fertility, making it, in prehistoric times, a smiling and populous land. However, the evolution of the Saharan climate is still open to debate. We still do not know whether the deterioration of the climate has reached its peak, has still to reach it, or has perhaps passed it. Moreover, the way the desert grows is not clear. Does it spread out round the center, or do the fringes of the Sahara shift alternately between the north and the south? We are still a long way from being able to reconstruct an exact chronology for the various climatic periods which from time to time made the Sahara habitable by man. Although extensive research has been carried out in one or two directions, such works are rare and no serious effort has been made to develop them. Yet they are of capital importance, not only from the scientific point of view, but also for a better understanding of a phenomenon that affects all human life. An understanding of the climatic changes that have taken place in the Sahara during the Quaternary era is essential for the study of ecological change, and soon, when each square meter of the Earth's surface will become vital for mankind, the better the past of the Great Desert is known, the more important its role will be. The historical progress of research since the journals listing research on the prehistory of the Sahara as a whole have ceased publication, it is not easy to draw up a schedule of the work already done. We do in fact possess such lists for the colonial period, but they are incomplete and often widely scattered. Some important discoveries have, for example, been described in military reports, which are somewhat difficult of access. The political division of the Sahara also accounts for the dispersal of works devoted to its prehistoric wealth, for not only the British, French, Italians and Spaniards, but also later the Germans, Japanese, Russians and others, have all made important scientific contributions to the discovery of the Sahara's past. Yet the desert has only relatively recently been penetrated. The first serious work on the prehistory of the Sahara was probably that published by the Abbé Richard in 1869 on the Algerian Sahara. Research in Egypt began at almost the same time with a letter from A. Arcelin dated February 1867. 9. But research in the Western Sahara had hardly begun by the beginning of this century. The expeditions led by Thoreau from 1876 on contributed greatly to work on the Central Sahara, particularly the important expedition of 1898 to 1900. 11. Meanwhile, though Lentz 1-2 had remarked on the presence of prehistoric objects at Taunet in 1886. Thenceforth the study. 8. Abbé Richard, 1868, pages 74-5. 9. 8. Arcelin, in a letter to the editor of the journal, Matériels pour l'histoire primitive de l'homme, published in volume V, 1869. 10. F. Thoreau, 1883. 11. F. Thoreau, 1905. 12. O. Lentz, 1884. 586. The prehistory of the Sahara. Of Saharan prehistory attracted a fair amount of attention, and its progress was hardly impeded even by 2 world wars. MENY scientists have, naturally, been attracted by the wealth of prehistoric remains in the Sahara. It would be impossible to give a complete list here, but one is struck by the valuable contributions made by the earlier authorities. The work of G. B. M. Flamand, 13 Frodenis 14 and Miss G. Caton Thompson, yes, for example, is indispensable for any serious study of Saharan prehistory. Prehistoric research in the desert has been more affected than any other kind of research by momentary preoccupations. Moreover, an understanding of its particular needs was for many years obscured by the fact that it was regarded as only subsidiary to the main interests of the various trans-Saharan expeditions. So the work was entrusted to amateurs or to specialists in some other subject who could not provide the required expertise. Moreover, in such a difficult environment, where lives may depend on every pound of baggage, the bulk, weight and cumbersomeness of prehistoric evidence led to its often being left behind. It should also be added that the Sahara is not an ideal place for travelers to wander in, still less does it allow the time or the means of making detailed investigations. This probably explains the many references to non-existent industries, complete absence of stratigraphy, nomenudum, and so on. In fact, the prehistory of the Sahara is as rich as that of any other region. As soon as time and money enabled specialized expeditions to investigate the Sahara, the situation changed rapidly. This occurred after the Second World War, and resulted in a number, unfortunately small, of excellent monographs that deal principally with the Haggard, the Sahara, Chad, Mauritania, the Libyan Desert, the Fezzan, and so on. A joint venture between science and industry even made possible the remarkable results recorded in the documents Scientific Missions Relate Genera Chad. Yet despite the desirability of investigating Saharan prehistory and the rich evidence available, it will be a long time before any kind of textbook is prepared. There is not even the popular account in this age, which has seen man reach the moon. All one can point to in Saharan prehistory are the many studies in detail and a few chapters in general works, in particular those of H. Alman, 17H. J. Hugot 18 and Art Warfrey, 1913. G. P.M. Flayman, 1902, pages 535 to 8, 1921, pages 114 to 15, R. Perry, 1937, list of the sites studied. 14. L. Frodenis, 1937. 15. G. Caton Thompson and E. W. Gardner, 1934. 16. H. J. Hugot, 1962. 17. H. Aliment, I 960. 18. H. J. Hugot, 1970. 19. R. Warfrey, 1969. 587. Methodology and African Prehistory. Attempt at a chronological account from the very beginning. Saharan prehistory took its points of comparison from Europe and, in particular, from France. Such terms as Clapto-Abythilian, Chelsea-Schuline, Mousterian, Ordination Flaps and Solutrean foliate arrowheads were current. The HE errors bred by this simplistic point of view still infect Saharan studies today. Saharan prehistory, like all prehistory, grows from the analysis of detailed monographs on particular industries, and monographs of this kind have not yet been written. Another regrettable consequence of the lack of order which reigns in Saharan research is the light-hearted attribution of precise social organizations to vanished ethnic groups without any real assurance that the evidence on which they are founded is valid. TWO remarks should be made on the subject of chronology. 21st. Nowhere in the Sahara has a sufficiently comprehensive stratigraphy been found to enable us to establish a precise prehistoric succession. Secondly, apart from the Neolithic period, we have no dates that would enable us to establish an absolute chronology. However, despite these difficulties we possess such excellent studies as those of J. Chaballon on the Sahara, 22H. For on Chad, 23 P. Camerd on Mauritania, 24 backed up by 20. Quaternary chronology, a succession of varying climatic phases. In most cases we only hope to establish the relative chronology for the Sahara as it is stratigraphically so poor. One of the best comparative chronologies has been suggested by J. Chaballon. Quaternary formations of the Western Sahara, Paris, CNRS, 1964. From the base to the top of the Sahara terraces in the northwest Sahara that author distinguishes. Upper Quaternary Illafrench and Megarian Middle Quaternary Taurushan Recent Quaternary Saturatian Holocene 21. Stratigraphy, the study and interpretation of the layers successively deposited in one place. It is easy to understand that a region subject to such climatological cataclysms as the Sahara should not contain much stratigraphy evidence. Sufficient stratigraphy sites do exist, however, to show that in many places there is a series of 3 terraces, old, middle and new, which testify to the existence of 3 long climatic periods. We should not over-schematize, however, for when we take microclimates into account the problem of the climatic periods that can be deduced from stratigraphy becomes extremely complex. Stratigraphy shows that by about 1000 before our era the Sahara was already a desert. 22. J. Chaballon, 1964. 23. H. 4, 1962. 24. P. Cameron, 1969-70. 588. The Prehistory of the Sahara. Solid peripheral studies on Algeria. 25. Morocco. 26. Libya. 27. And so on. In the light of such studies we can get a fairly accurate idea of the outlines of Saharan prehistoric chronology. But there are too few paleontological data and, in general, too little organic material that can be used for radiocarbon dating for us to take an absolute chronology any further back than the Neolithic. See Table 23.1, page 600. Though of course Table 23.1 is drastically simplified, and in particular it does not account for an important complex of large blanks, often made by the Levallois technique, found on top of a collection of thin, bifacial blanks, small in size and light in weight, that probably date from the end of the Acheulean. Such complexes have been found at Tiguelcamine, 28 at Burku, 29 and other places. Finally, we should point out that up till now nothing has been found that would enable us to speak of an Upper Paleolithic 30 period in the Sahara, since the term is not borne out by the facts. Still less is it possible to talk of a Mesolithic period, although in any case that particular term is going out of use. Table 23.1 meters away perhaps give rise to a more detailed chronology. It correlates what is known of climatic trends and population densities in prehistoric times. Although very few skeletons have been found together with industries which will allow of classification, yet those that have been found indicate the very great antiquity of man in the Sahara. The appearance of man in the Sahara, the pebble culture industry and the banks of extinct rivers. It is often possible to see terraces that were formed when the waters were still flowing. Such terraces form three distinct levels, called, for the sake of convenience, old, middle and late terraces. At Jebel Irani, 120 kilometers east of Insalon in the Algerian Sahara, pebble tools have been found in the old terrace. We know that such pebbles are the first tools to bear recognizable marks of having been worked by man. In most cases they are simply river pebbles from which a few planks have been struck to fashion the rough, uneven cutting edge. It has been postulated 25. L. Below, 1955b. 26. P. Biberson, 1961b. 27. C. B. M. McGurney and R. /V. Hay, 1955. 28. H. J. Hugot, 1962. 29. Hibbett. 30. Paleolithic. The recognition of Homo habilis as the probable ancestor of present-day man has necessitated a new chronological division of this period, but this has not modified the problems relating to the Sahara. It appears at present that there was no Middle Paleolithic or Paleolithic period in the Sahara, but rather the Terminal Paleolithic that is represented by the Aterian, therefore post-Mousterian and separated from the Neolithic by only a brief gap. 31. 8. Bonnet, 1961. 589. 3. Code. SCO. The Prehistory of the Sahara. That such objects belong specifically to the industries of Homo habilis. In the Saharan region of Niger, on the banks of the Tefetsasset, 32 an ancient tributary of Lake Chad, large quantities of pebble tools have also been found, but in a less significant situation than in Irani. Other collections, as in Adalef, 33 have been scattered or destroyed, while the series found in the Satter of 34 is too small to provide sufficient material for study. But we can say for certain that the pebble culture was widely found throughout the Sahara, which at that time was humid and very different from the desert we know today. Unfortunately no animal or human fossils from this period have been discovered, and all we can do is to put forward the hypothesis that these very rough tools, which are found more or less throughout the Sahara as well as at sites where large quantities remain, really are those that were fashioned and used by our most distant ancestors. Homo erectus, maker of bifacial tools. At the close of the pebble culture a technical change appears leading to the evolution of tools which were still in use at the beginning of the Lower Paleolithic. The mystery surrounding this great human and technical advance remains complete. In the Sahara no skeleton of the makers of this remarkable tool and of the derivative form, the cleaver, which suggests a forest environment at that period has been found. but although we know nothing of the ecology of the pebble culture, we are slightly better informed on that of Homo erectus. The Sahara was then a region of Great Lakes with high water levels and sufficient rainfall to maintain a type of vegetation indicative of an almost cool climate. The large animals NOW found only south of the desert then lived throughout the Sahara. One remarkable fact is that the torrential downpours typical of the following period destroyed or severely damaged the deposits of sediment which accumulated almost everywhere in the Great Lakes, and moreover the very dry spell between the preceding period and the period under discussion in a white well have hastened the process of destruction. Because of the widespread disturbance of these deposits, reliable stratigraphy evidence is extremely rare, although the number of bifacial tools found in the Sahara is enormous. We shall not go so far as to say that the fossil man of Chad 3-5 made bifacial tools. Vorfrey 36 puts him at the beginning of his chapter in the lower and middle Paleolithic in the Sahara, but since we have no knowledge as to 32. H. J. Hugot, 1962, pages 151-2. 33. H. J. Hugot, 1955b. 34. J. Chabellone, 1956. 35. Y. Cottons, 1962, pages 455-9. 36. R. Vorfrey, 1969, page 21. 591. Methodology and African Prehistory. Whether this venerable ancestor made tools, we can only describe him as an extremely interesting paleontological discovery. Tihudain was first mentioned by Puvarar in 1864-37 and was visited by E. F. Gautier and M. Regas in 1932. 38. The Endoshulian industry has been found there with remains of rhinoceros, elephants, hippopotamuses, bovines, buffalo, warthogs, zebra, crocodiles, gazelle, and so on. All the material in Tihudain is late Acheulean, and it often includes carved bone or wood, so that it was at advanced stage of the Acheulean and does not follow directly from the culture already described. Not far from Tihudain there are two very fine Acheulean deposits with a variety of bifacial tools, often very small and almost S-Bakian, and of cleavers. This is the Adieberg deposit, 39, discovered by a soldier in 1934 and first published by H. L. Hope and H. Kelly in 1936. 40. This surface deposit, like the one at Wadi Tekfetses at 41 discovered by the Brilliant Genera expedition, is not easily dated, but their importance has not inspired the research necessary to get full value from the material. Tubelbala and Tachfianga 42 are well known for their bifacial tools in reddish quartzite sandstone, and more especially for their impressive range of cleavers that show a highly developed technique. In the same part of Africa, J. Chabellone and H. Alamet have found an undisturbed deposit of a developed Acheulean culture which either immediately preceded the flake industry or else should be included in the Middle Acheulean. This is the case at Mazer, Beni Abbas and Curzes. 43. At Chibikat Menau the Sahara in the Algerian Sahara. 44. There would be a significant series of artifacts except that, unfortunately, they are very few. At in Ekr, Minuit and Iraq. 45. The Middle Acheulean is buried under sediment containing scattered objects of the Aterian. A large number of Acheulean objects have also been found at Adalef, 46 at Shirta, 47 at El Base, 48 at Eshahainig, 49 in the Western Sahara at 37. H. Puvarar, 1864. 38. E. F. Gautier and M. Regas, 1934. 39. H. L. Hope and H. Kelly, 1936, pages 217-26. 40. This surface stratum is a good illustration of the difficulties of distinguishing between the dominant industry and later contamination by more recent objects. 41. H. J. Hugot, 1962. 42. B. Champold, 1953. 43. H. Aliment, I 960, pages 421-3. 44. J. Chabellone, 1956, page 231, 1958, pages 431-43. 45. H. J. Hugot, 1963. 46. /V. P. Fonte et al. 1938, pages 17 to 21. 47. M. Allenite, 1948. 48. P. Biberson, 1965, pages 173 to 89. 49. 8. J. Arkell, 1954, pages 30 to 4. 592. The Prehistory of the Sahara. Target, 50 and in the Libyan Desert. 51. We may conclude that the Acheulean is present in the whole Sahara, but we are unable to date it for, apart from 4 or 5 sites, no stratigraphy deposits have been found. The most important were careful excavations and observations remains to be done. An obscure point, the flake industries both in Europe and in the Sahara. The Lower Paleolithic is characterized by the basic bifacial tool, which began in extremely rough forms that were at first called chalene, and developed into elegant, balanced, perfectly chipped and finished pieces like those found at Mikok. In the Sahara the precursors of bifacial tools are small worked pebbles, but we soon find a radical change in the techniques used in stone flaking, and to this new mastery of the difficult art of stone preparing the refinement and perfection of form is partly due. In Europe and the Sahara such progress was made possible only by the discovery of the virtues of using a more pliable striker, made of bone or wood, rather than a stone hammer, which could not be used with great precision because of the force of impact it required. But although the bifacial tool is in a sense the characteristic, or fossil director of the Lower Paleolithic, it is far from being the only object made by Homo erectus. We have many reasons for believing that as soon as the technique was evolved flakes were used too, and also a large number of the many chips that came off the core. That is why it is quite normal to find the preponderance of flake tools at the dawn of the Middle Paleolithic. 52 flake tool is thus a development rather than a discovery, the development which also takes the form of reducing bifacial tools in size as well as using them more and more as weapons. On the other hand, what is revolutionary is the widespread use of the levallois technique. It appears very early in the Sahara, and influenced the techniques used in the making of certain bifacial tools from Tapshi Edgat, 53 as well as at Burku and Timbro-Urine. But despite the very early appearance of the levallois technique, it does not seem to have changed the style of life of its inventors, who were certainly not Neanderthal-men, or they would have adopted a different style of life requiring lighter tools and weapons, quite opposite in conception to the heavy bifacial tool and cleaver. The really striking fact, although it has hardly been noticed, is not so much the absence of any Mousterian or Mousteroid period in the Sahara, but that the Aterian period that takes its place, and which in fact has a Mousterianizing influence, is above all an industry providing weapons for hunting. The ability to make a tanged weapon implies not only that the concept of a shaft was known, but also 50. M. Almagro Bash, 1946. 51. G. Caton Thompson, 1952. 52. However, we should not forget that the real mutation is human, and is marked by the appearance of Neanderthal-men, the instigator of the Mousterian industries. 53. J. Teixier, 1957. 593. Methodology and African Prehistory. Those of the Assegai and the Bulis. In brief, it is the industry of a migratory people, which is why its implements are so light compared with those of preceding cultures. At the present stage of research it would appear therefore that in the Sahara the Aterian 54 takes the place occupied elsewhere by the Mousterian, and shares several of its features such as the use of the levallois technique, which appears not only in the style of retouching but also in the typology of the finished objects. However, the Aterian differs from the Mousterian in two essential characteristics, by the presence of tanged objects that might serve as boring instruments, either retouched or in a rough form, scrapers, balls or even drills, two noticeable statistical differences from the classical Mousterian industry. Apart from this, however, the idea of a Mousteroid substratum remains strong, and although we have no Aterian skeletons it is quite usual to attribute this interesting industry to a relation of Neanderthal-men. We note that the Aterian is a North African industry that was diffused southwards 55 and stopped roughly along the banks of the Great Lakes of the southern Sahara. As it progressed southwards it gradually changed until it produced such works as the dazzling culture of Booz, 5/6 word as well as the classical collection of coarse, blades, flanks, scrapers, notches, double foliated arrowheads made by the bifacial technique and stone balls. We find very fine hafted arrowheads also made by the bifacial technique, one of which is nearly 19 centimeters long. The Atiran culture is extremely widespread. We find it in Tunisia, 57 Morocco, 58 Algeria, 59 Salaro, Tidikelt where it uses an Arankari fossil successfully as a basic material, 60 and Mauritania where Adder roughly marks its limits. 61 We find it everywhere, in a Hagar 62 at the ADM. 54. Atiran, an industry of North African origin, with an essentially Mousterian basis and in addition a series of hafted objects. The Atiran is a later culture than the Mousterian. The stone tools, which show a marked influence of the Levallois technique, become more highly developed as it moved across the Sahara. The southernmost limit of the Atiran seems to have been the great southern lakes that are now found only in Chad. And the northwest borders of Chad sites dating from 9000 to 8000 before our era have been found. This industry dates from the late rather than the middle Paleolithic. 55. H. J. Hugot, 1967, pages 529 to 56. 56. H. J. Hugot, 1962, pages 158 to 62. 57. M. Gruet, 1954. 58. M. Antoine, 1938. 59. M. Regas, 1922, pages 467 to 72. 60. E. F. Gautier, 1914, Miner de Saint Martin, 1908, M. Regas, 1923. 61. R. Gitat, 1972, pages 29 to 33. 62. H. J. Hugot, 1962, pages 47 to 70. 594. The Prehistory of the Sahara. Berg, 63 at Tehoudain, 64 at Adder Booz, 65 and also in the Fezan, in Zamril, and at its most easterly point at Karga in Egypt. 66. It is very difficult to place the Atiran in a chronological sequence. It may have begun c. 35000 before our era. And the borders of Chad its progress seems to have been arrested by the last high water level, and if that were the case then it would have lasted till 9000 to 7000 before our era. But all this is mere hypothesis. It seems logical that an industry so obviously influenced by the Mousterian should be succeeded by an Upper Paleolithic period, but two questions then arise. First, can we really put the Atiran, which did after all come very late, in the Middle Paleolithic? In his masterly thesis, L. Balau thought it would be wrong to succumb to such a temptation. Secondly, what do we know of a true Paleolithic in the Sahara? Very little really, and the industry discovered by R. M. Uny at Wadi Esht 67 has not yet yielded up its secrets. The Capsian style collections of stone tools found on the southern border of the Todmite 68 are still a matter of much debate. Only the series at Merdij al-Mawadi My on the Todmite Plateau in the central Algerian Sahara, which was found long ago, gives any proof of the presence of a true Capsian ensemble in the region now covered by the Sahara, and that is hardly enough to carry a conviction. In order to provide a chronological solution, it has therefore been suggested that the Atiran should be placed under the uncontroversial heading of Terminal Paleolithic. The hiatus in order to describe a developed post-Atiran industry of Adder Booz Niger J.D. Clark recently used the word Mesolithic. This term, which is, fortunately, gradually falling into disuse, has no meaning generally speaking, and does not correspond to anything known in the Sahara. Its use can only reinforce Arkell's error, 69, which was quite understandable at the time when he was working on the Nile. In the current state of research, French prehistorians prefer not to use this term. But this does not mean that the problem of the Paleolithic does not exist, for the Egyptian civilization III, with its intrusive geometric microliths, 7 degrees precedes the Neolithic though without merging with it, and there are some. 63. J. Bobo, 1956, pages 253 to 68. 64. L. Belout, in C. There Aberge and L. Belout, 1955, pages 287 to 92. 65. H. J. Hugot, 1962, pages 158 to 62. 66. G. Caton Thompson, 1952, 1946. 67. An unpublished monograph has been given to the Department of Prehistory of the IFVN of the University of Dakar. 68. H. J. Hugot, 1952, 1955 A. 69. 8. J. R. Kell, 1949 A. 1953. 70. E. Vineyard, 1923, pages 1 to 76. 595. Methodology and African Prehistory. Indications, though these are rare, that it may have spread farther than the zones where its presence has been recognized. The Neolithic we know little or nothing of the genesis of the Neolithic peoples. 71. They seem to have spread through the Sahara from different points. According to M. C. Chambliss, 7 to 1 factor in the Neolithic peopling of the Sahara is crossbreeding, with blacks at one extreme and Middle Eastern peoples, ordinarily grouped under the name Mediterranean, at the other. The Neolithic population of the Sahara was far from homogeneous. If we take the waves of settlement in order, the oldest seems to be that which formed on the banks of the Nile, near Khartoum and Eshehaini, and then spread westwards along the banks of the Great Lakes. This wave does not seem to have spread farther than the eastern fringes of Akkar, nor to have penetrated into the forests, but it did send out two feelers northwards, one into the Haggard as far as the northern edge of the mountains before Tassili Najj, and the other from Tilemsi towards the Sahara. This brilliant civilization is easily recognized from the distinct character and the richness of its pottery decoration. Its industries, however, are very difficult to describe precisely, as the Neolithic of Sudanese tradition made use of all that came to hand. The first inhabitants of the Sahara were fishing, hunting, food gatherers, who were fond of hippopotamus and the berries of the nettle tree Keltizeski, but who did not disdain fish from the lakes, freshwater turtles, or watermelons. The fact that they made adzes, hoes, grinders, grindstones and similar objects does not mean at all that they engaged in any form of agriculture. 73. Though they constantly filled jars. 71. Neolithic, descriptive of new techniques, in particular pottery, stone polishing, the beginnings of domestication, agriculture and urbanism that supplemented the highly developed lithic industry of the Paleolithic. The oldest Neolithic sites in the Sahara can, it seems, be attributed to the 5th and 6th millennia before our era. The term Neolithic does not necessarily presuppose a knowledge of all the techniques mentioned above. However, one of the most remarkable phenomena, which merits some consideration, is the cooking of food. The chemical changes resulting from this had a decisive influence on the physiological development of man. The Saharan Neolithic in its various forms is a technical explosion, rather than a revolution as it has often been called. 72. M. C. Chambliss, 1968. 73. Agriculture, the deliberate cultivation of selected plants on areas of land worked specifically for that purpose. We may deduce that a culture had a knowledge of agriculture from the following: 1. Statistically valid palynological proof. 2. The existence of traces of cultivated land. 3. The discovery of identifiable vegetable fossils. The presence of a so-called agricultural range of tools is not in itself significant, as hoes may have been used to dig up clay for pottery, grindstones may have been used for grinding pigments, wild grains, medicines, etc. Agricultural is therefore a term that can only be applied in accordance with its fixed rules and not on the basis of unverified hypotheses. 596. The prehistory of the Sahara, with nettle tree berries, and though imprints of gourd seeds are often found during the excavation of sites, this gives rise at most to the hypothesis of a proto-cultivation. There was a division of labor for specialized pursuits divided up into specialized tasks. Stone polishing was widespread, and the range of weapons was extensive. Hunters used bows and slash or throwing spears, bone harpoons and fish hooks were used. Polished stone axes, hoes and adzes formed an important part of their equipment. They were adept at making beads from hard stones such as amazonite, chalcedony, hematite and carnelian. Specialists had perfected very clever drilling equipment, 74 consisting of burin splinters, needles and drills used with resins and fine sand. A lot of grinding equipment has been found, and it is often very fine. It proves that even if there was no true milling, at least the art of grinding was known. The product that they ground was certainly ochre, but also perhaps wild grains, berries, dried grasses, vegetable dyes, or medicines. Their pottery deserves special mention, not only for its richness of decoration but also for its beauty of form. It should be noted that conical dimple bases and elongated amphora-shaped vessels are not found, though there are a few pouring lips, handles and knobs. We are quite well informed, therefore, on the first wave of settlers. It was followed, farther to the south, by another African people which spread into the forests, where it was so well hidden that despite its importance this Neolithic culture remained for long undiscovered. It has been identified quite clearly in Guinea, hence its name of Guinean Neolithic, though in fact it probably originated in Central Africa. 75 A little later the Neolithic in the Capsian tradition, the result of the Neolithization of the old North African Capsian culture, began moving southwards. It reached Mauritania from the northeast, and got as far as Haggard, since at Mean, yet it has been found just below the surface on Sudanese Neolithic sites. We are less certain of its eastern limits, as there are no usable monographs for Libya. The Capsian Neolithic tradition is more austere than the Sudanese Neolithic. Its pottery has little, if any, decoration. But while the Sudanese lithic industry is often hackneyed, the Capsian uses a very rigorous technique, and in the Sahara is enriched with a dazzling proliferation of weapons and arrowheads. The polished stone is often very beautiful, and the bowls made from hard stone and zoomorphic statuettes 76 are masterpieces that quite make up for the bad impression made by their pottery. In this species of Neolithic culture we find small beads pierced for threading that are sometimes fragments of enchronite, but more often discs made out of small pieces of ostrich eggshell. Whole eggs have been blown to make containers, and some have been engraved with line drawings. 74. M. and J. Goskin, 1965, page 237. 75. R. Dielcroix and R. Vorfrey, 1939. 76. Collections Préhistoriques. Musée Ethnographie et de Préhistoire du Baixado, Alger, Album No. 1, Paris, EMG, 1956, plates 107 to 10. 597. Figure 23.2 Pottery from Akrijat, Mauritania. 598. The Prehistory of the Sahara. We note that the Ibero-Maurusians and the Capsians were not the same people. The latter lived mainly on the high Algerian plateaus, where they left those strange heaps of shells known as escargotiers. The Ibero-Maurusians settled on the shores of the Mediterranean, from Tunisia to Morocco, but we do not know for certain how these Cro-Magnoids settled in North Africa, nor how the two peoples were distributed. What is certain is that both underwent Neolithization in North Africa. The Ibero-Maurusian Neolithic people, living as they did near the sea, could not but be influenced by it, and if one continues south down the Atlantic coast of Morocco one finds mounds of mussel and oyster shells, and farther on of various cinelas, which are still eaten in Senegal. The whole coast of the Moroccan Sahara and of Mauritania was occupied by a strange Neolithic industry that has been studied little if at all, and is characterized by rough pottery with little decoration, hearthstones and occasional stone tools. It would be very interesting to know how this industry was formed and where it came from, for although it was influenced by the Ibero-Maurusian culture in Morocco, we know nothing of its constituent elements. There is a fifth stream of Neolithic culture that has since drawn the attention of specialists, the one discovered at Aberboos and called Tenerian for that reason. J.D. Clark, WHO, has actually seen the site, suggested that it might be representative of the Seneran Neolithic, but this is quite impossible unless Seneran is taken merely to mean a very extensive area. The Tenerian, discovered by Joubert in 1941, 77, is characterized by lotus-shaped projectile points, thick concave scrapers, elementary saws and hafted axes, as well as its typology and statistical composition, and it is, again, impossible to call it a classical Saharan Neolithic culture as that term is reserved exclusively for the two cultures, Sudanese and Capsian, which cover most of the Sahara. Warfree, WHO was often tempted to relate everything to the Capsian Neolithic. 78 says that the Egyptian influences that can be recognized in the Algerian Sahara spread, in their most highly perfected form, as far as the Haggard, and, further on, the Tenerian sites represent the apex of the Saharan Neolithic industry and evoke irresistibly the pre-dynastic Egyptian culture. 79 We should however point out that outside Tenera there is no clear Egyptian influence to be found, despite Warfree's assertion. We still have to find out, therefore, how the obvious outside influences reached the magnificent Tenerian industry with its characteristic beautiful green jasper artifacts. One should however be careful not to take the notion of a facie too far. WENOW know with what varied exuberance a particular people may respond to the different limitations placed on it by such factors as the 77 G. Joubert and R. Warfree, 1941-6. 78 R. Warfree, 1938, pages 10-29. 79 R. Warfree, 1969, page 66. 599. Methodology and African Prehistory. TBLE 23.1 Outline. 1002 plus 1000. 1002 negative 2000. 2002. 5000. 5002. 7000. 7002. 15,000. Of Saltaran prehistoric chronology. Last wet period. Silting up of tributary beds. Drying up of springs. First wells. Subsidence of alpine microclimates. Last glacial erosion of valleys. Reeds growing in lakes. Ancient dunes, type II. Aukar. Final level of Great Lakes containing diatoms. Silures, elephant, hippopotamus, rhinoceros. Torrential rainfall. Ancient dunes, type I. Volcanic activity. Ferruginization of conglomerates. And of erosion. Formation of tectosacet terraces. Flowing of great rivers. Formation of great lakes. Violent erosion. So-called pre-Islamic monuments. Recent Neolithic. Tisha. Phaetlion. Borkau. Early Neolithic. Miniet. Ingezum. Tilemsi. Atiran. Satiro. Tidikelt. Mauritania. Air. Ashuli and IIVII as established by Baberson 1061. Pebble culture. Ecology, the subsoil and the minerals which are found in it, and where the presence of jasper and flint MOY result in masterpieces in stone. Quite different results will be obtained where the only material is a fragile sandstone. Haderer Booz and Gossaler 80 are the same, but one has to study the pottery, the discs and the axes in order to realize this. For all that the two industries having COMMON is the quality of the stone working. A few words remain to be said on a very fine Neolithic facie found in southeast Mauritania along the course of the Dartiship. 81 Extensive excavation in this region has shown that this rather late industry is linked. 80 H. J. Hugot, 1962, pages 154-63 and 168-70. 81 H. J. Hugot et al., 1973. 600. The Prehistory of the Sahara. To an exceptional group of dry stone villages which are of great interest because of the extent of urbanization. 82 And the skill in fortification which they show. Here at last we have proof that from 1500 before our era the local communities ate millet, and so for once we see some sense in the enormous amount of grinding equipment found in the ruins of these villages. The Dartiship culture is African, as can be seen from its pottery and other characteristics. It may have come from the east, most likely from neighboring Tilemsi, but that is only a working hypothesis. It may thus be seen that the Neolithic involved a number of influential secondary currents acting on a COMMON foundation which can be identified in the pottery and less often from the particular techniques used in their stone or bone industries. The H Neolithic can be regarded as lasting from 5000 before our era to about the beginning of the first millennium before our era, during which period the level of the lakes constantly sank, until eventually the varied large fauna retreated to the edges of the desert, especially to the south. The flora dwindled, and man in his turn emigrated with his herds. The fauna of this period were inherited from the Aterian, which ended when the lakes were at their last high level. On the shores and in the waters of these lakes were found the so-called Ethiopian fauna, which included rhinoceroses, crocodiles, crocodilus, niloticus, hippopotamuses, elephants, zebra, giraffes, buffaloes and warthogs. Catfish, sea areas and Nile perch-lates niloticus teemed in the waters, as did freshwater turtles trionyx, while the pastures were graced by goats and antelopes. The only surprising thing about such a catalogue is that it applies to the Sahara. The flora is even more staggering. At the beginning of the Neolithic, the hazel, the liverty, the willow and the ash were still to be found. The Limicolouse shell found at Minyet that wider in the Algerian Sahara indicates an annual rainfall of at least 500 millimeters, and that heather-covered parts of the mountains. However, this vegetation soon dwindled and was replaced by one characteristic of a more arid zone with cedars, the Aleppo pines, junipers, olives and the gum and nettle trees that were such an important feature in the diet of the population. The lakes were also well provided with shellfish, and in some places the remains of enormous collections of Unio shells are found. Handy of the characteristics of the Sahara at the beginning of the Neolithic culture was the string of lakes all isolated from each other. The Sudanese Neolithic populations tended to migrate along the shores of the lakes, which offered suitable sites for settlements as well as varied food resources. 82. Urbanism, the study of the layout of a group of dwellings, usually occupied by a sedentary population and precisely organized according to the division of labor and religious ideas of the occupants. The only Saharan group that conforms to this definition is Dartiship in Mauritania, a settlement that began in about 2000 before our era. 601. Methodology and African prehistory. The Sahara, the cradle of agriculture. The idea that the Sahara was a cradle of agriculture has been put forward on a number of occasions, often without considering that this might be a misuse of such a significant term. Agriculture cannot be said to be proved by the presence of tools or other objects of possible agricultural application. Proof is provided only when fossil grains or pollens bear out the hypothesis put forward concerning the application of tools or objects. Collections of millet grains found at Tiship in Mauritania confirm Munson's 8.3 and Bono's 8.4 ideas on this subject. Apart from that, we know that the Saharan Neolithic people collected large quantities of berries, Kelti's sp, and nettle tree berries, which they certainly used for food, and at Minyet and Tiship cucurbitaceae seeds probably of watermelons, though not citrulus colocynthis, have been found. These two plants provide the staple of food gathering or, at the most, indications of proto-cultivation, but not of agriculture, which means preparing the soil deliberately in order to grow selected plants. In this definition we do not have much evidence to offer. That Minyet, 85 palynological analysis of Neolithic deposits has thrown no precise light on the existence of any form of agriculture. That Aberbu's a summary analysis gave no results either, not at Ben Asako, nor at any of the many sites studied from this point of view. The only remains found in Neolithic sites that showed for certain the vegetable products were eaten are seeds of Zizapus lotus, Kelti's sp, and various types of wild grain. To these we should also add the imprints of Panacetum found by Munson and the millet grains discovered at Tiship in fossilized turf. But before any conclusions can be drawn, we must await the systematic analysis of the Neolithic deposits. Despite its enormous potential, palynology has been little used in the Sahara, but even if some plants were cultivated there, it seems unlikely that it was a spot where conditions favored the development of the cereals commonly consumed in North Africa. It was, almost everywhere, stock raisers who, long ago, succeeded the hunter-gatherers, and the fact that stone tools such as hoes, grindstones, grinders, weights for balancing digging sticks, and picks have been found more or less everywhere does not ipso facto imply that agriculture in any real sense existed. In Egypt, where agriculture was extensively developed, very precise traces are found, and in such places as Tiship in Mauritania, where the sedentary population may well have practiced agriculture, such traces are also to be found. But, according to the present state of known 83. P. J. Munson, 1968, pages 6 to 13. 84. T. Morneau, 1963. 85. G. P. M. Flayman, 1921. 602. The prehistory of the Sahara. Ledge. The situation is unlikely to have been the same elsewhere, and we should not forget that by before our era the Sahara was almost completely desert. But although the ending of the wet period hardly encouraged agriculture, this does not mean that all proto-cultivation, or the selective food gathering that preceded it, were unknown. Moreover, we may be certain that experimenting with vegetable foods must have stimulated the search for particular species, which, in itself, was an early form of selection. But cultivation is only possible among a population that is sedentary, or at least seasonally fixed, and in most of the Sahara the Neolithic period at its height is more reminiscent of nomadic encampments than of organized villages, though some of these certainly existed. The origins of domestication and the Neolithic Sahara had its own way of life. The stock raisers of Tassili and Ajj were contemporaries of the artists of the flying gallop chariots. Although their exact period is not known, they probably lived at about the time when the invading peoples of the sea were repulsed, then they tried to conquer Egypt. In any event, these stock raisers developed the art of herding to such an extent as often to surprise the uninitiated, for, at its height, this civilization had developed such skillful methods of managing stock as to presuppose a long experience. The Egyptians seem to have tried to domesticate many kinds of animal, but we can only tell this from bas-reliefs. Without them we would never have known that they tried to tame members of the feline and canine families, gazelles and even hyenas. What was the situation in the Sahara? The Sudanese Saluki, that invaluable helper of the Nemadi hunters, seems to be of very ancient stock, and it is probably the Saluki that is depicted in the paintings of the stock-raising peoples. There are also other indications, but none of them conclusive. We know that in 2000 before our era both cattle and dogs were found in Akkar, but the rock paintings do not show which animals MN might have attempted to domesticate in earlier periods. The Neolithic way of life. We know that the people of the Sudanese Neolithic were endlessly curious about new techniques. They continued working stone and produced a marvelous range of arrowheads and tools, usually very light, made of flint flakes that had been retouched in various ways, balls, several forms of scraper, geometrical microliths, saws, and so on. What is new is the subtle stone polishing technique used for axes, hoes, pouches and chisels. Hard stone vessels, Amazonite, cornelian and quartz beads and small balls that may have been used in slingshots were added to their range of artifacts. We also find a profusion of fixed grindstones and grinders, which are not. 603. Methodology and African prehistory. Necessarily a proof of a knowledge of agriculture, and of kilowatts, the stones once used for weighing down digging sticks that are still in use in South Africa and among the Pygmies. The collection is completed by a dazzling series of pottery vases, already typical of the later art of Africa south of the Sahara in shape and decoration. Bone was also worked and was used for making harpoons, balls, needles, potter's combs, smoothers and maybe daggers. The people of the Sudanese Neolithic made the best possible use of the lithic resources wherever they lived, and this led to the idea that they came from several different ethnic stocks. But in fact theirs was a stable and united culture, as is proved by the unity of inspiration in their pottery decorations if by nothing else. We should also add that these peoples, already molded by certain types of social organization, must have known how to manage boats, and it is not impossible that they may have sailed on the lakes in reed boats like those still found in Chad and called Kobiain. The people of the Capsian Neolithic differ in many ways from their Sudanese counterparts and predecessors. The latter left the Sudan in several waves, going westward but not, it seems, reaching the Atlantic coast. They were black-skinned, often true Africans. But the people that set out from the high plateaus of Algeria were more Mediterranean, and they had inherited from their Capsian ancestors a real gift for flint working. They had an astonishing range of tools. Fine flakes on which the working is hardly visible are often reminiscent of jewelry. Balls, sharp points and little scrapers are found along with geometrical microliths made from the waste of the flaking process in the shape of trapezes, rectangles, triangles and segments of circles. They were not ignorant of hunting, since they made innumerable arrowheads that have now unfortunately become the object of a large-scale tourist trade. There is an abundance of polished axes, but they are not compact and squat as is usual in the Sudanese Neolithic. The Capsian culture had a wider range of stone tools than the Sudanese, and also used far more varied techniques. They too knew how to polish hard stone bowls and to make marvelous sculptures like the Bull of Silet, the Ram of Tamentit and the Gazelle of Imakasan. But their pottery is far less rich in form and decoration, not because the artists lacked imagination. Their skill in decorating ostrich eggs which they used, whole, as containers and, broken into bits, to make innumerable beads proves that this is not the case. Many fragments of ostrich shell exist decorated with fine line drawings. They also, of course, had fixed grindstones and grinders, and we know for certain that some of these were used for grinding pigments, probably for painting their bodies. The Neolithic of the coast is little known. The work done on this subject has not yet been published, but we do know that all along the Atlantic coast from Morocco southwards countless shell mounts have been found, some of them veritable tells, mixed up with ashes and potsherds. This is true as far down as Senegal, at which point the proto-historic ethnic movement seems to have taken over. It still remains too. 604. The prehistory of the Sahara be explained why at the frontier between Mauritania and the Rio de Aro the round, or flat-bottomed pottery COMMON in the Sahara is replaced by a marvelous pottery with distinctly conical bases. As yet, however, nothing has been published on this problem. Farther east, at Agar Buz in Air, there is a stratum that cuts right through all the other known aspects of Saharan Neolithic cultures, whatever their origin. This is the Tenarian. Using bright green jasper to make quite magnificent tools, many of the shapes found are reminiscent of the Egyptian Neolithic. It is true that common forms such as flat discs, low touch-tapped projectile points, nip scrapers known as crescents, and hoes polished by use might just be coincidental, but they occur so often that this seems unlikely. Certain fixed grindstones associated with this brilliant culture are similar to those found in Egyptian bas-reliefs, so that one is almost led to believe that Agar Buz was colonized by people who had close links with the Nile, although it is strange that they used pottery similar in all respects to the Sudanese Neolithic. We should not forget, however, that the latter has its archetypes at Eshkahini. During an epoch that was more humid than today, the forests south of the line of lakes must have been greener and denser than they are now, and this may explain the fact that the people of the Sahara never crossed this barrier. The study of the Neolithic culture of these forests has hardly begun. For purposes of convenience and precedence it has been called Ghanaian, but in fact it seems to have originated much farther afield, maybe even in Zaire. Conclusion: the fascinating study of the past of the Sahara is still taking its first halting steps, and it offers to specialists and to men of goodwill an opportunity that should be quickly seized, before the exploitation of its last natural resources destroys forever our chances of solving problems which, in the long run, concern the past of the whole of mankind. It is only by becoming aware of his past that man can determine his future. Our experience comes not only from the present but also in a direct line from prehistory. To deny this would be to deny that the study of prehistory is any rational basis or scientific value. The prehistory of the Sahara is no longer a matter for individual research. It is a collective enterprise, requiring teamwork and money. It is tragic to see scientific work on the Sahara so abandoned, so neglected. The people responsible for this huge and harsh desert should make themselves responsible for providing the men to discover its secrets. 605. Plate 23.1 Flat-notched axe from Gosalaram, Niger. Plate 23.2 Cleaver from Tben Asako, Mali. Plate 23.3 Chopper tool pebble culture. Plate 23.4 Chopper tool pebble culture from Aleph, Algerian Sahara. From Aleph, Algerian Sahara. 606. Plate 23.5 Lower Paleolithic hand from Tachi Edgat, Algerian Sahara. Plate 23.7 Large bifacial double point, ATRN industry, from Timi Mount, Algerian Sahara. Plate 23.6 Lower Paleolithic cleaver from Tachi Edgat, Algerian Sahara. 607. Plate 23.8 ATRN points from Aleph, Algerian Sahara. 608. Plate 23.10 Neolithic pottery from Dartiship, Mauritania. Plate 23.9 ATRN bifacial double point from Agar Buz V, Niger. 609. Plate 23.11 Neolithic arrowheads from Ingezim, Niger. Plate 23.1 to Neolithic group tax from Aberboos, Niger. Plate 23.13 Neolithic Polish tax from the Fonte region, Chad. 610. The prehistory of West Africa. C.T. Shaw. Climate and environment. The main climatic and vegetation belts run east and west across the whole expanse of West Africa. The highest rainfall occurs near the coast, and the farther north and inland one goes, the less it becomes. The desert to the north is fringed along its southern edge by the dry Sahel Strip. South of this comes the Great Savanna Belt. Between the savanna and the wet tropical rainforest which fringes the coast lies a zone of derived savanna which was once forest but which has been turned into savanna by the activities of man. Rainfall in the area is markedly seasonal, falling predominantly from April to October with peaks in July and October in the south and from June to September in the north. These rains are carried on southwest winds which have gathered their moisture from the Atlantic. However, the intertropical front runs east and west across West Africa, dividing the tropical maritime air mass formed over the South Atlantic from the dry continental air mass over the Sahara. The position of the front fluctuates with the seasons of the year. In January it is farthest to the south, with the consequence that the northeast trade winds from the dry northern air mass reach right down to the Guinea coast, bringing with them the dramatic fall in humidity. The awareness of this weather and vegetation pattern is fundamental to the understanding of the prehistory and archaeology of West Africa. The location and extent of the different vegetation zones, and the position of the intertropical front, have varied at different times in the past, affecting the circumstances in which MN was living in West Africa at different periods. Set into these vegetation zones are a number of geographical features which make local modifications in the general pattern. The Fura de Talent and Guinea Islands, the Togo/Atacora chain, the Barchi Plateau and the Mangarod/Cameroon Highlands, the inland delta of the Niger and its great northward bend, Lake Chad, and the delta at the mouth of the Niger. There is a break between Ghana and Nigeria in the continuity along the coast of the tropical rainforest belt, which is known as the Dahomey Gap. Forest, savanna, desert, XX. E80. 612. The prehistory of West Africa. Early man skeletal remains. West Africa has not so far produced remains of early forms of MN or hominids such as have been found in eastern and southern Africa, nor artifacts of correspondingly early date. Can it be assumed that there were such beings in West Africa? Is our present lack of data due to the fact that these hominids were not living at the time in West Africa, or is it simply because the evidence has not yet been found? This is a question which it is impossible to answer at present, but no research effort comparable to that in East Africa has yet been made in West Africa. It also has to be admitted that deposits of the right age appear to be scarcer in West Africa, and it is notorious that in the prevailing conditions of high humidity and soil acidity, preservation conditions are very much worse. 3. This fact is illustrated by data of a much later age. A distribution MP of Africa plotting finds of skeletal remains of the late Stone Age shows a complete blank in the Zaire West Africa area. 4. Yet since the compilation of HAT map, dated finds have been made in Nigeria and Ghana which showed that the blank was indicative of a state of research, not of an absence of human occupation. 5. The same may then be true for the earlier period we are now considering. 6. And may also be true of a distribution MP of the fine places of vertebrate fossils of lower and middle Pleistocene age, which shows a similar blank. 7. As far as one can see, there must have been ecological conditions in certain parts of West Africa very similar to those which supported the Australopithecines of East Africa, but of course this does not mean that these areas in fact were occupied. There are many areas of tropical rainforest which could support gorillas today, but in fact they are only found in two circumscribed areas. 8. And in spite of some similarity of conditions, the West African savanna does not support the same collection of game types as East Africa, nor in the same density. 9. Any positive piece of evidence for thinking that early hominids were to be found in suitable areas of West Africa early in the Pleistocene is provided by the craniofacial portion of a skull found 200 kilometers west-southwest of Larcho. It was named Chadanthropus atsaris, 10 and was first thought to be 1. R. E. F. Leakey, 1973 b. 2. M. Leakey, 1970. 3. J. D. Clark, 1968a, page 37. 4. C. Gable, 1966, page 17. 5. C. T. Shaw, 1965b, 1969b, D. Broadwell and C. T. Shaw, 1971, C. Flight, 1968, 1970. 6. Y. Cottons, 1966b, page 373. 7. Hibbett, page 374. 8. J. P. Dorst and P. Dandelot, 1970, page 100. 9. Hibbett, pages 213, 223. 10. B. G. Campbell, 1965, pages 4, 9, 613. Methodology and African Prehistory. An Australopithecine 11 but was later regarded as more akin to Homo habilis. 12. The uncertainties in this case stem from the lack of secure dating and from the fact that the skull is only fragmentary. Further examination of the skull, with its combination of archaic and advanced characteristics, has suggested that it shows clear signs of evolving towards Homo erectus. 13. Representing a more advanced stage of the hominids, and has cranial capacities ranging from 850 cc to 1300 cc. Once again, there are no examples of this form from West Africa, although specimens of this type, called Atlanthropus mauritianus, have been found in Algeria. 14. Artifacts. Although prehistoric man-made tools of bone and wood as well as of stone, wood is rarely preserved, and soil conditions in West Africa militate against the survival of bone. Apart from utilized and roughly trimmed flanks, the earliest and simplest types of stone tools consist of pebbles or lumps flanked by percussion to form crude chopping and cutting tools with edges anything from 3 cm to 12 cm long. They are known as Old Dowan type tools, after Oldaway Gorgon, Tanzania. Such tools are found in many places in Africa, and the early men who made them may well have spread over most of the savanna bushy grasslands of Africa. Examples of such tools are known from a number of places in West Africa. 5. But it is not at the moment possible to be assured if any of them genuinely date from the same period as the Old Dowan industry of East Africa, which may be put in the period between 2 million and 0.7 million years ago. Careful investigation of pebble tools found along the Gambia River in Senegal demonstrated that some were likely to be of Neolithic origin and others to have derived possibly from the Late Stone Age. There was no stratigraphical evidence for an industry of pre-Acheulean H. 1.6, so we can only be sure that pebble tools belong to an early period if they are independently dated by being found in situ in deposits which can be dated, either relatively or absolutely. Paleontology gives some relative dating for the Yaon deposits which produced Chadanthropus, but unfortunately, there were no associated implements. From the evidence of fossil bones of the extinct hippopotamus Maguncula which came from a depth of 58 meters in a well in Borneo. 17. It is likely that deposits of the Chad Basin contain paleontological material of Pleistocene age, and as likely as 11. Y. Cottons, 1961. 12. Y. Cottons, 1965a, 1965b, H. B. S. Cook, 1965. 13. Y. Cottons, 1966a. 14. C. Berenberg and Art Hofstetter, 1954, 1955, C. Berenberg, 1954, 1966. 15. O. Davies, 1961, pages 1 to 4, 1964, pages 83 to 91, Armani, 1963, R.C. Soper, 1965, page 177, H. J. Hugot, 1966b. 16. Armani, 1968, page 1283, C. Barbie and C. Descamps, 1969. 17. C. M. Tatam, 1944, page 39. 614. The Prehistory of West Africa. Not archaeological material as well, but it lies under a mantle of later drift of great thickness. Climatic changes in Europe. There were several different glaciations during the Quaternary, and the four principal ones were given the names of rivers in Germany. It is now realized, however, that whatever overall rhythm and pattern there may be in glacial phenomena, there are many local variations which have to be taken into account, with the result that local names are used for each particular region. The ensuing picture is one of greater complexity but probably a lot nearer reality. 18. The same kind of thing happened when early research workers in Africa found evidence in reached lake levels, in erosions and in deposits of gravels which were taken to indicate that it dated from the Quaternary when the African climate was very wetter than at present. Such periods of increased rainfall were christened pluvials. Since the concept of glacial periods was already evolved for the north temperate zones, what more natural than the idea that when there was a glacial period in Europe and North America there was a corresponding pluvial period in the warmer tropics. 19. In time, the idea of 3, and then 4, African pluvials became orthodox belief. 20. And it was supposed that they corresponded to the glaciations of the European Ice Age. 2. Although an alternative theoretical scheme was put forward suggesting that one African pluvial corresponded to 2 northern glaciations. 22. That it was possible to put forward the view of this kind illustrates how almost non-existent was any true chronological correlation. In any case, geological correlations over wide distances should be based not on climates, but on rock formations. In addition, the evidence for pluvial events is somewhat equivocal when compared with that for glaciations, and has caused confusion. 23. In time, the very evidence for pluvials in Africa was called into question. 24. West Africa has been no exception to this pattern of extrapolation, and efforts have been made to use sequences derived from other parts of Africa to give meaning to data which are otherwise isolated or difficult to interpret. 25. More recently, however, 2 things have served to improve the scientific. 18. R. F. Flint, 1971, B. W. Sparks and R. G. West, 1972. 19. E. J. Wayland, 1934, 1952. 20. L. S. B. Leakey, 1950, 1952. Resolution 14-3, page 7, J. D. Clark, 1957, PXXXI, Resolution 2. 21. E. Nelson, 1952. 22. G. C. Simpson, 1957. 23. J. D. Clark, 1957, PXXXI, Resolution 4. K. W. Butzer, 1971, pages 312-15. 24. R. F. Flint, 1959 B. 25. G. Bond, 1956, pages 197-00 B. E. B. Fag, 1959, page 291. O. Davies, 1964, pages 9-12. J. Piaz, 1967. 615. Methodology and African Prehistory. Approach for West Africa, an increase in the amount of relevant research. 26. And the emergence of a new theoretical framework for climatic change in Africa. 27. We have no reliable geological or geomorphological information on West Africa bearing upon climatic change earlier than the period of the last glaciation of Europe. Study of Lake Chad has shown high lake levels from 40,000 before our era. 28. This high lake is marked by the Bam Ridge upon which Maiduguri stands, and which here runs northwest and southeast. Both ends of this stretch then swing round to the northeast, running up to enclose Larjo and the whole of the Bodo Depression and Bar El Ghazal. The ridge, regarded as a lagoon bar rather than as the actual shoreline, may have taken 6,000 years to form. 29. The ancient lake stood at a height of 332 meters above sea level, compared with the present height of Lake Chad of 280 meters, and at times overflowed over the Badr spillway and drained down the Gainway. It seems therefore that during this wetter period in West Africa the forest is likely to have extended a good deal farther north than it does today, although whether as far as lat. 1 degrees and 30 or the present 750 mm I so high at 31 it is impossible to be sure until we obtain confirmation from palynology. approximately coincident with the last maximum of the last glaciation in northern Europe, beginning from around 20,000 before our era. It appears that our West African area was much drier than at present. During this time the West African rivers were discharging into an ocean which was some 100 meters below its present level because so much water was locked up in the polar ice sheets. Thus the Bainway cut a channel some 20 meters below present sea level at Makurdi and deeper still at Yola, while the sunk channel of the Niger at Jebel is 25 meters below sea level and deeper than this at Onitsha. 32 The Senegal also flowed in a channel well below its present level, but at its mouth it was blocked by vast sand dunes, as was also the course of the Middle Niger. Lake Chad was dry at the time and sand dunes formed over its floor and in parts of northern Nigeria where there is now more than 850 mm mean annual rainfall, indicating at the time less than 150 mm. Although only the events at the mouth of the Senegal and around Lake Chad have any kind of absolute dating attached to them, the other evidence fits best in terms of a generally dry period around 18,000 before our era. If sand dunes were forming at the latitude of Kano, the savanna and forest belts must have been pushed far to the south. In fact it is. 26. Association Sénégalaise Portefeuille du Quaternaire, 1966, 1967, 1969, Kate Burke et al., 1971, Kate W. Butzer, 1972, pages 312-51. 27. E. M. Van Inderondacker, 1967. 28. M. Servant et al., 1969, 8. T. Grove and A. Warren, 1968, Kate Burke et al., 1971. 29. 8. T. Grove and R. 8. Polian, 1964. 30. O. D. Avise, 1964. 31. O. D. Avise, I 960. 32. C. Vodtek, 1962. H. For and P. Alloward, 1967. 616. The prehistory of West Africa. Probable that most of the forest disappeared except in relict areas of the highest rainfall such as coastal Liberia, part of coastal Ivory Coast, the Niger Delta and the Cameroon Mountains. By IO before our era conditions seem to have begun to get wetter. The Mali Niger overflowed over the Tayasil, and Mega Chad, as it has been called, 33 again had a vast extent. The sand dunes formed in the previous dry period were reddened as a result of seasonally wetter conditions. Spreads of charcoal dated to the 11th and 7th millennium before our era that may indicate bush fires and savanna-type vegetation surviving at this latitude to those dates. 34 During this period the forest would again have spread northwards from the relict areas near the coast where it had survived during the preceding dry period. The most satisfactory theory to relate the late Quaternary climatic events of West Africa with the events of Northern Europe derives from evidence that is accumulating that changes in temperature were worldwide and that these caused a shift of the weather belts on either side of the equator, modified by the shape of the large land and ocean masses. 35 WHEN world temperatures fell. A glaciation resulted in northern latitudes and extended the polar anticyclone southwards. The weather zones beyond were compressed towards the equator, so that in West Africa the intertropical front was displaced from its present position southwards. This resulted in the dry northeast winds of the dry season months blowing for longer period and more strongly across West Africa, and the rain-bearing winds of the southwest monsoon blowing more weakly and reaching less far during the rainy season. This would account for a dry period in West Africa roughly coinciding with a northern glacial period. At the same time it was wetter than at present in the northern Sahara because the storm tract from the Atlantic Ocean came in south of the Atlas Mountains instead of passing north of them. As world temperatures rose, the ice sheets retreated northwards, so did the intertropical front, and the sea levels returned to about their present level. It became drier in the northern Sahara as the Atlantic storm track moved northwards, but there was a sufficient reservoir of groundwater and of vegetation in the Sahara for the final desiccation to be delayed until after 3000 before our era. Then it became too dry in the Sahara for the people living there to continue their way of life. Naturally this had repercussions in the areas lying to the south. The Stone Age. The terms Paleolithic, Paleolithic and Neolithic are still applied to North Africa, but for a long time archaeologists in sub-Saharan Africa have 33. R.E. Morrow, 1963, M. Serving */ 1969, 34. C.T. Shaw, 1970, pages 58, 91, 35. E.M. Van Inderen Becker, 1967, 617. Methodology and African Prehistory found it more valid to use their own terminology, derived from the realities of the continent and not from a European system imposed from outside. This new terminology was officially endorsed by the Third Pan-African Congress on Prehistory 20 years ago. Hence the terms Early Stone Age, Middle Stone Age and Late Stone Age will be used. 36. The chronological boundaries of these divisions of the Stone Age in sub-Saharan Africa vary somewhat from area to area, but very roughly they may be thought of as 2500 to 50000 before our era for the Early Stone Age, 50000 to 15000 before our era for the Middle Stone Age, and 15000 before our era for the Late Stone Age. As new knowledge accumulates, such simple divisions and datings come to be modified and demand a more complex picture. The use of the term Neolithic has come under increasing criticism when applied to sub-Saharan Africa, since it is ambiguous whether it indicates a period, a type of technology, or a type of economy, or a combination of the three. 37. The Early Stone Age in West Africa. The Ashuali in Eastern, Southern and Northwestern Africa. The old Dow and industrial complex was succeeded by that known as the Ashuali, characterized by bifaces. These are tools of oval or pointed oval shape with a cutting edge all round, carefully trimmed from both sides. One variety, known as a cleaver, has a straight transverse cutting edge. Although women and children probably still provided at least half the food intake by means of collecting wild fruit, nuts and roots, MNNOW banded together in cooperative activities to hunt large game animals. The use of fire was known, at any rate by the end of Ashualian times. The type of early man responsible for making Ashuali and implements, wherever this is known, was that called Homo erectus, with a brain size considerably less than that of modern man, but in other ways very similar in body form. What are usually regarded as early types of bifaces formerly called Sherline are absent in the Sahara, but have been claimed for Senegal, 38 the Republic of Guinea, 39 Mauritania, 40 and Ghana, where they are said to be stratigraphically established in a rolled condition to the Middle Terrace 4. Whatever this means in relative chronological terms, the HE area of their distribution has been mapped for 2, and this is said to indicate a colonization from the river Niger along the Atacora chain and the Toto Hills. 36. J.D. Clark, 1957, PXXXIII, Resolution 6. 37. W. Bishop and J.D. Clark eds 1967, pages 687-899 C.T. Shaw, 1967, pages 9-43, J.C. Vogel and P.D. Bowman, 1972. 38. R. Corboyle, 1951. 39. P. Creech, I-95 IAB. 40. R. Money, 1955 8. 41. O. Davies, 1964, pages 86-91. 42. O. Davies, 1959. 618. The Prehistory of West Africa. The later stages of the Ashuali, marked by fine hand axes made with the advanced cylinder hammer technique, are prolific in the Sahara north of about I6° N. Perhaps this distribution is to be correlated with the penultimate glacial period in Europe, or possibly the earliest maximum of the last WRM glaciation. At such a time there would have been more rainfall in the northern Sahara, and the desertic zone would have moved southwards and been unattractive for human occupation. The an exception to this seems to have been the high ground of the Jos Plateau, where the climate would not have been so arid and would have provided the open or lightly wooded grasslands of the type favored by Ashuali and MN. It therefore formed as it were a promontory of habitable lands projecting southwards from Air and the main Saharan Ashuali, an area north of I6° N. There is a radiocarbon date of more than 39,000 years. Page. 434 material associated with the Acheulean tools in the basal gravels filling in channels cut in a preceding wetter period. At a time when Acheulean man favored the Jaws Plateau, it is likely that the Fonte Massif would also have been suitable for human occupation, and a certain amount of Acheulean material has been found in this area. 44. There is also a scatter of middle and late Acheulean deposits around and to the north of the upper Senegal River. This may be regarded as linking the Fonte area to the prolific sites of Mauritania. Acheulean material has been recorded 45 in southeastern Ghana and along the Togo/Atacora chain of hills, suggesting a possible route from the north which would have provided a favorable environment, but the penetration does not seem to have been very strong. Though Acheulean material is firmly established stratigraphically in the area, and with small collections and individual pieces, it is often very difficult to assign them with certainty to the Acheulean typology alone, since so many of the forms overlap or are similar to those used in the succeeding Sangoan industries. 46. The Sangoan. There are difficulties of definition over the Sangoan industrial complex. 47. Whether there is a true Sangoan in West Africa at all has been questioned. 48. In many parts of sub-Saharan Africa a complex of industries came into being, following the Acheulean, which retained some of the toolkit of the latter, such as pick and biface forms, though the cleaver disappeared and spheroids became rare and there was a much greater emphasis on picks, often of a heavy and massive form. Choppers, often made of flamed pebbles, also occur. 43. G. W. Berenson et al., 1965. 44. J. D. Clark, 1967 b. 45. O. Davies, 1964, J. D. Clark, 1967 b. 46. O. Davies, 1964, pages 83 to 97, 4, I37-9, 47. J. D. Clark, 1971 a. 48. B. Y. Agusu, 1973. 619. Methodology and African Prehistory. In West Africa, Sangoan material has a more southerly distribution than the Acheulean, 49, suggesting a new pattern of settlement. The N industry from Cap Manuel at Dakar, which was formerly regarded as being Neolithic, 50, is now regarded as Sangoan, 51, or perhaps as a late development from it. The same can be said of some material collected from Bamako. 5-2. In Nigeria, Sangoan material is found particularly in the stretch of country south of the Jos Plateau and north of the tropical rainforest, associated with river valleys. It also occurs in gravels at heights of 10 to 20 meters above modern river level. 53. The N industry from the Niger Valley near Busa, which consists mostly of worked pebbles and is without picks, is regarded on geological grounds as nevertheless being contemporary with the Sangoan. 54. A spread of Sangoan material down the Atacora-Togo chain and into southern Ghana has been reported. 55. Such material is rare in northern Ghana but fairly widespread in the south. Elsewhere in Africa, 5-6. The Sangoan is allocated to dates after 50,000 before our era, and it has been suggested that the Sangoan industrial complex and the Y represent the need to adapt to more wooded country in an increasingly arid period. 57. In West Africa there are no radiocarbon dates for a Sangoan industry. Sangoan material in the Asokra-Kona railway cutting in southern Ghana all occurred above Davies's beech ivy, which he equates with the Gotwig interstadial at the latest. 58. A stratigraphical position which does no more than give a terminus post-quart which we should expect. If the gravels 10 to 20 meters above the Niger around Juba were laid down when the river was graded to the upper Inchiorian high sea level. 59. The presence in them of unrolled Sangoan artifacts suggests a date of about 30,000 before our era, while the rolled specimens could be contemporaneous or older. It is possible that the southerly, riverine and woodland distribution of the Sangoan in West Africa represents a way of life adapted to dry conditions before 40,000 before our era, after which late chaff began to fill up and spread. Perhaps the game which had formerly been hunted became scarcer and moved southwards, and the emphasis on picks may have indicated the need both to dig up roots and tubers and to dig pit traps for animals which could no longer be so easily hunted in the open. 49. J. D. Clark, 1967b. 50. R. Corbulet A.I. 1948, page 413. 51. O. Davies, 1964, page 115. H. J. Hugot, 1964, page 5. 52. O. Davies, 1964, pages 113 to 14. 53. Hibbett, pages 113 to 14. R. C. Soper, 1965, pages 184 to 6. 54. R. C. Soper, pages 186 to 8. 55. O. Davies, 1964, pages 98, 100. 56. J. D. Clark, 1970 c. page 250. 57. J. D. Clark, 1959, page 149. 58. O. Davies, 1964, pages 23, 137 to 42. 59. H. For and P. Alloward, 1967. 620. The Prehistory of West Africa. The H.E. Middle Stone, the G.E. in W.E.S.I. Africa. The term Middle Stone Age is used to describe a group of industrial complexes covering roughly the time span 35,000 to 15,000 before our era. In West Africa, industries belonging to the Middle Stone Age have been identified with less certainty than in the rest of sub-Saharan Africa. Rare specimens of Lupemban type have been found in Ghana 60 and Nigeria 61, but none which give satisfactory stratigraphical indication of their date. In the Jos Plateau and in the Lura Hills to the north of it, considerable collections of material characterized by the faceted butts of the prepared core technique have been found, which have been classified as belonging to the Middle Stone Age, 6 stratified at 10 OK. Between the basal gravels containing the Schuleiden material and the later deposits containing the Nog culture. 63. They do not have affinities with the Lupemban industrial complex, but rather with Middle Paleolithic industries of northern Africa of generalized Mosteroid type, and probably belonging to a more open savannic way of life. Comparable industries have been reported from Ghana and the Ivory Coast, 64 from Dakar 65 and from the Central Sahara. 66. There is a radiocarbon date from a piece of wood from the deposits at Zenabit in northern Nigeria, one of the alluvial sites producing Mosteroid material, of 3485 plus minus 110 before our era, but the precise position of this piece of wood in relation to the stone artifacts is unrecorded, and the date is a good deal younger than would be expected for an industry of this type. 60-70 An archaeological occurrence at Timassus, near the coast of Senegal, containing as it does among other things bifacially flamed projectile points in addition to Middle and Upper Paleolithic type artifacts, was at first considered to represent the mixture of Neolithic and earlier elements. 68 More careful examination, however, showed that these bifacial points were an integral part of a stratified industry which did not contain other Neolithic elements, so that it is regarded as a type of Mosteroid which locally contains these elements and here replaces the Atiran of farther north. 69 The latter is an industrial complex belonging to the end of Middle Paleolithic times in Algeria and extending southwards into the desert. 60. O. Davies, 1964, pages 108 to 13. 61. Found on the surface in the Afipo area by Professor D. D. Hartle and formerly in the collections of the University of Nigeria, Nsukka. 62. R. C. Soper, 1965, pages 188 to 90. 63. B. E. B. Fab, 1956a, pages 211 to 14. 64. O. Davies, 1964, pages 124 to 42. J. D. Clark, 1967b. 65. R. Corbulet et al., 1948. R. Corbulet, I-95 IAB, C. D. Richard, 1955. 66. J. D. Clark, 1967b. 67. G. W. Berenson et al., 1965. 68. T. Deegan, 1956. 69. R. Gillett and C. Descamps, 1969. 621. Methodology and African Prehistory. Davies sees an extension of this industry into West Africa and calls it the Guinea-Atiran. 70. But the evidence adduced is not convincing and is doubted by most workers. 71. The He Late Stone. The Ge over most of Africa. The Late Stone Age is characterized by the development of very small stone tools, called for that reason microliths. These are tiny pieces carefully trimmed to be slotted into arrow shafts to form points and barbs, and to make other kinds of composite implements. They demonstrate that their makers were possessors of the bow and that hunting with it formed an important part of the economy. At this point we become bedeviled by the word Neolithic, and its ambiguity of meaning. It is better avoided in Africa whenever possible, certainly in sub-Saharan Africa. 72. But one has to take account of the persistence of this usage for North Africa and the Sahara. Industries occur widely in the Sahara which have been termed Neolithic because of their toolkit, and which, in the central area, date from the 6th millennium before our era. Conditions were moister than today, supporting the Mediterranean type of flora, and cattle pastoralists who may or may not have been growers of cereal crops. 73. There is clear evidence for the advent of food producers in Cyrenaica by 4800 before our era. 74. But the Neolithic of Capsi and tradition, widespread in northwest Africa following preceding Paleolithic cultures there, has now been shown to give no evidence of food production although it extends into the 2nd millennium before our era. 75. At one time finds from Rufiscate in Senegal were attributed to the Neolithic of Capsi and tradition. 76. But they are probably best regarded as belonging to the general microlithic continuum of West Africa. 77. In addition to this occurrence near Dakar, this microlithic continuum, or Guinea microlithic, is widespread in the eastern half of West Africa, but in the western half appears to be absent at the most southerly sites, in the area of Liberia, Sierra Leone and the Republic of Guinea. The first archaeological sites to be excavated in West Africa were a number of caves and rock shelters in the southern part of the Republic of Guinea, some of which were dug into over 70 years ago. 78. In some there are bifacial pieces recalling forms earlier. 70. O. Davies, 1964, pages 116 to 23. 71. H. J. Hugot, 1966a. 72. W. W. Bishop and J. D. Clark eds. 1967, page 898, resolution Q. J. D. Clark, 1967a, C. T. Shaw, 1967, page 35, resolution 13, P. J. Munson, 1968, P.N. Some authors do not share this opinion. 73. H. J. Hugot, 1963, pages 148 to 51, F. Maury, 1965, G. Camps, 1969, 74, C. P.M. McBurney, 1967, page 298, 75, C. Rubin, 1971, 76, R. Vorfrey, 1946, H. Aliment, 1957, pages 229 to 33, O. Davies, 1964, page 236, 77, H. J. Hugot, 1957, 1964, pages 4 to 6, C. T. Shaw, 1971a, page 62, 78, E. T. Amy, 1900, p. Gatelyhard, 1907, L. Desplagnes, 1907a, E. Hue, 1912, R. Docubert, 1922, Abbe Dogbra, I-93 IR. Dielcro I. Exender. Vorfrey, 1939 C. T. Shaw, 1944, 622. The Prehistory of West Africa. Then the Late Stone Age, which have been regarded by some as hoes, and therefore as indirect evidence of agriculture. This possibility must certainly be borne in mind, as rice replaced yams as the staple crop in the western half of West Africa, and African rice, Oryzea glabellum, was probably domesticated in the area of the Middle Niger Delta. 79 flat, broad pieces of quartzite roughly chipped into shape are also regarded as hoes and as evidence of cultivation in Guinea. 80 But there are no clear associations or dates for these. The majority of the Republic of Guinea sites produced microliths, ground stone axes, grinding stones and pottery, as did also a site in Guinea-Bissau. 81 Some of the Guinea sites had pottery, although in the Grotto de Coquimbo pottery is said to occur only in the upper level. 82 Excavations in the rock shelter at Blanda, in the southeast corner of the Republic of Guinea, also produced an industry with ground stone axes and pottery together with large bifacial tools reminiscent of the Kindia and Fonte de caves, but without a microlithic element. 83 Microliths were similarly absent from the cave site of Ienthamus, in Sierra Leone, where the lowest level produced a small flake industry in quartz. Compared by the excavator to the Ishagon of Lake Edward, middle level bifolially flamed picks and hoes resembling some of the material from the caves in the Republic of Guinea, and which the excavator assigns to a Lukemband industrial complex, and the upper level ground stone axes and pottery, from which there are two thermoluminescent dates indicating the period 2000 to 1750 before our era. 84 A microlithic element is present, however, in two other rock shelters excavated farther north in Sierra Leone, the Iagala and Kama Bay, with radiocarbon dates indicating a span of the Late Stone Age here from 2500 before our era up to the 7th century of our era. 85 It looks therefore, as if in this western part of West Africa there was some kind of Middle Stone Age tradition which may also be present at Dakar and at Bamako, which survive comparatively unchanged in the most southerly sites and did not adopt or develop a microlithic technique. The reasons for this may well be ecological, since the microlithic technique is associated with a savanna zone economy in which hunting played an important part. If one plots a distribution of the sites without microliths Conakry, Ienthamus, Blanda, and draws the boundary between them and those with microliths Kama Bay, Iagala, Kindia, and Hampasir, one finds that this boundary runs very close to the boundary between the forest and the savanna. The technical innovations of ground stone axes and pottery subsequently arrived. 79. R. Porters, 1962, pages 197 to 9. 80. O. Davies, 1964, pages 203 to 30. 81. A. D. Medius, 1952. 82. E. T. Amy, 1900. 83. Bihalas, 1950, 1952, Bihalas and Armani, 1953. 84. C. S. Kuhn, 1968. 85. J. H. Gatherton, 1972. 623. Methodology and African Prehistory. In the area from the north, the date of the advent of these influences is in the middle of the 3rd millennium before our era, which is just when the desiccation of the Sahara became widespread. It is therefore reasonable to connect the two events and see the influence of people moving out of the Sahara, although we do not yet have the osteologica evidence for it. These people probably also brought cattle with them, perhaps the stock ancestral to the Ndm breed of the Fonte de which developed an immunity to trypanosomiasis. In most of the rest of West Africa, the microlithic continuum underlies and precedes the techniques of making pottery and ground stone axes, which appear to be grafted onto the microlithic tradition rather than to replace it. At Karankaro near Bamako, the lower layer with coarse microliths and worked bone was stratified below an upper layer, with more refined microliths, ground stone axes and pottery. 86 In Nigeria, the rock shelters at Rop. 87 on the Bachi Plateau, and at Iwolaru in the western state, had provided microlithic levels without pottery and ground stone axes stratified below microlithic levels which do have them. At Iwolaru, the radiocarbon date of 9200 before our era has been obtained from near the base of the lower level, and the transition to the upper seems to be a little after 3000 before our era. 88 At Midjiro Cave, Old Oyon, the microlithic industry was recovered which had no associated pottery or ground stone axes, but the sample was small and it is undated. 89 In Guinea, the Borsum Procavitatify produced an association of microlithic pottery and ground stone axes, but this also is undated. 90 There is a late phase of the Late Stone Age in Guinea which has been called the Kintampo culture. Following an early phase with pottery and microliths, The Kintampo culture has ground stone axes, stone armlets known from Saharan Neolithic sites, and a peculiar type of hatched stone rubber. The early Punt phase is dated to before 1400 before our era, and the later one has dwarf goats and domestic cattle of a breed closely resembling the West African dwarf shorthorn. 91 Even in southern Mauritania, microliths are present with pottery and ground stone axes in the earliest phase Akrigate of the Tiship sequence at some date before 1500 before our era, but disappeared in all subsequent phases. 92 Along the northern margins of our area, in the Sahel zone immediately south of the Sahara Desert, there was a somewhat different situation in the later part of the Late Stone Age, with adaptations to the local ecology evidenced in the material culture. At Harkura Kingcat, north of Gao, cattle. 86. G. Submowski, 1956. 87. B.E.B. Fag, 1944, 1972, E. Ohio, 1972 A. 8. Rosenfeld, 1972, 8. Fag, 1972 A. 88. C.T. Shaw, 1969 B. 89. F. Willett, 1962 B. 90. C.T. Shaw, 1944, 91. O. Davies, 1962, 1964, pages 239 to 46, 1967 B, pages 216 to 22, C. Flight, 1970, P.L. Carter and C. Flight, 1972. 92. P.J. Munson, 1968, 1970. 624. The Prehistory of West Africa. Pastoralists lived on mounts above the level of the seasonal streams between 2000 and 1500 before our era, and had pottery and thick equipment which included ground stone axes, Sahara-type bifacial arrowheads though not hollow-based ones 93, and an occasional microlith. Fishing was an important aspect of the economy, as is widely evidenced across the southern Sahara in late Neolithic times. 94. A somewhat similar situation obtained at Bama, in northeastern Nigeria, 1,000 years later, where cattle keepers were probably also growing sorghum on the fertile clay lands left behind by the shrunken Lake Chad. While they had pottery, ground stone axes and a prolific bone industry, they had no small thick industry of any kind. 95. A specialized adaptation to completely different ecological conditions occurred at the opposite end of our region along the southern margins of West Africa, on the Atlantic coast. Here, Late Stone Age peoples were exploiting the abundant shellfish of the lagoons and estuaries, both for food and as bait for fishing, leaving behind huge mounds of shells. In the Ivory Coast such mounts have been shown to extend from 1600 before our era up to the 14th century of our era. 96. And in Senegal one contained a ground axe made out of bone. 97. Those which have been examined in the casemates are of post-Stone Age date. 98. The end assemblage with pottery, ground stone axes and thick industry without microliths was found at Fonte in southern Nigeria, where radiocarbon dates give the time span of the industry as from 3000 to 1 before our era. 99. Informando po 4 main stages of a late Stone Age complex have been recognized, 100 with pottery and ground stone axes, but no microliths. The radiocarbon date in the 6th century of our era was obtained for the earliest stage, which, if correct, puts the sequence very late. The wasted form of the axes shows affinities with similar ones from southeastern Nigeria, degrees Cameroon and the Republic of Chad. 10-to summarize, the Late Stone Age in West Africa can be divided into two phases. Phase I, beginning not later than 10,000 before our era, has two phases. Phase A has microlithic stone industries and is associated with hunting in the savannah. Phase B belongs to the forested area in the most southwesterly part of West Africa and is without microliths. Phase I, beginning soon after 3000 before our era, may be considered to have for Phase C adds pottery and ground stone axes to microliths over most. 93. R. Mani, 1955 B. 8. Smith, 1974. 94. T. Morno and R. Mani, 1957. 95. G. Cotton, 1967, 1969, 1971, 96. R. Mani, 1973. I.U. Olson, 1973. 97. J. Joyer, 1947. R. Mani, 1957. 1961. Pages 156 to 62. 98. O. Linares D. Sapir, 1971. 99. D. D. Hartle, 1966. 1968. 100. 8. Martin Del Molino, 1965. 101. R. 8. Kennedy, I. 960. 102. J. D. Clark, 1967 8, page 618. 625. Methodology and African Prehistory of the Savannah. Fates B. In the Sahel, has a fishing element in its economy, virtually no microliths, and a bone industry which includes harpoons, fish hooks, and so on. Facies C is coastal, with an economy adapted to exploiting the resources of the lagoons and estuaries. Facies D is associated with a forest environment and has pottery and groundstone axes but no microliths. WHE and the cattle pastoralists of the Sahara first moved southwards in the 3rd millennium before our era. They not only encountered microlithic hunters to the south of them, but moved out of an area where flint was available into an area where arrow points and barbs had been made of quartz or some other stone from which it is more difficult to make a bifacial arrowhead. So for the most part they seem to have adopted the microlithic technique of the indigenes for tipping and barbing arrows, as they saw it was just as effective even if not so aesthetically pleasing to modern eyes. Those who reached Tantarasso in central Ghana in the second half of the 2nd millennium before our era were exceptional in retaining their characteristic bifacial arrowheads. 103. If this southward movement of people out of the Sahara meant an infusion of population into the indigenous stock, it might have had little obvious influence on the physical type, since they were both Negroid anyway. 104. If, as seems likely, the emigrants were speakers of Proto-Nilo-Saharan, the small groups might well have lost their own languages and adopted the prevailing Niger-Congo language of the indigenes. Only large groups, such as the ancestors of the Songhai, would have retained their OWN language. 105. Food production. The change from dependence on hunting, fishing and gathering the fruits of the wild, to crop raising and stock keeping, is the most important step which man has taken in the last years. This revolution did not take place in a single location and spread to the rest of the world, but there were a limited number of foci where such developments evolved. For Europe, Western Asia and Northeast Africa, the main focus was in the hill country of Anatolia, Iran and northern Iraq. Here were developed the cultivation of wheat and barley and the domestication of sheep, goats and cattle. Later, the techniques of food production were applied to the great river valleys of the Tigris/Euphrates, Nile and Indus, with the added techniques of drainage and irrigation. 106. By the 5th millennium before our era there were domesticated sheep and cattle in Egypt and cereals were being grown. Degrees 7 at 103. O. Davies, 1966a, 1967a, 1967b, page 163. C.T. Shaw, 1969c, pages 227 to 8. 104. M. C. Chamia, 1968, D. Broadwell and C.T. Shaw, 1971. 105. J. H. Greenberg, 1963b. 106. G. Clark, 1969, pages 7 off. P. Jaco and G. W. Dimabds, 1969. 107. G. Caton Thompson and E. W. Gardner, 1934. D. Sutton, 1968, page 490. F. Vendorf et al., 1970, page 1168. 626. The Prehistory of West Africa. Present WE have evidence for domesticated cattle earlier than this in the Central Saharan Islands, and some evidence, though slender, for cereal growing. 188. Difficulty of starting up cereal agriculture in sub-Saharan Africa as a result of example from the Nile Valley is that the crops anciently grown there, wheat and barley, are winter rainfall crops which can only be grown with difficulty south of the intertropical front in the summer rainfall areas. What was necessary here was the domestication of suitable indigenous wild grasses, which gave rise to the African cultivated millets. The most important of these was sorghum bicolor or Guinea corn, which was domesticated by the first half of the second millennium before our era in the area between the Sahara and the Savannah, from the Nile to Lake Chad. 109 of their wild grasses were domesticated to become pearl millet and finger millet. African rice has already been mentioned. 11 degrees around Tiship, in southern Mauritania, there is evidence for the use of the grain of local grasses, but around Iwu before our era, the proportion of pearl millet jumps from 3% to 60%. 1. In the moister zones of West Africa, the important staple was the yam, of which more than one African variety was domesticated. 112. And although this may have taken place as long as 5,000 years ago, we do not as yet have actual archaeological or botanical evidence for this. A long history of yam cultivation combined with the benefit of complementary food values from the nuts obtained from protected or tended oil palms will help to account for the density of population in southern Nigeria. 3. The development of food production, while a prerequisite for urbanization, does not automatically of itself lead to the growth of towns and cities. It seems that certain other circumstances have to be present, such as a build-up to a certain level of population pressure and a shortage of agricultural land. 114. In sub-Saharan Africa, the incidence of malaria increased as a result of agricultural clearing and the presence of larger settled communities, so that the increase in population following the adoption of agriculture was slower than it otherwise might have been. 115. And in most areas of sub-Saharan Africa there was not at the time a shortage of agricultural land. 116. Nevertheless, a sufficient agricultural basis had been established by the first millennium of our era to support such ancient kingdoms as Guinea, Mali, Songhai and Benin. 108. F. Maury, 1965, G. Camps, 1969. 109. J.M. J. D. Webb and J.R. Hartland, 1971. N.O. R. Porters, 1951 B. 1958, 1972. In P. J. Munson, 1968, 1970. 112. D. G. Corsi, 1967, 1972. 113. C. T. Shaw, 1972, pages 27 to 8. R. Fries, 1965. 114. M. C. Webb, 1968. 115. F. B. Livingstone, 1958. S. L. Wiesenfeld, 1967. D. G. Corsi and J. Alexander, 1968. 116. C. T. Shaw, 1971 B. pages 150 to 3. 627. Methodology and African Prehistory. The coming of metal in spite of proposals a long time ago, on good methodological grounds, to abandon in Europe the Free Age system of Stone Age, Bronze Age and Early Iron Age. L7 Its very convenience has fostered its continued use. West Africa as a whole was hardly touched by the Bronze Age, but a facies of it reached down from Spain and Morocco to Mauritania, where nearly 130 copper objects have been found and where the rich source of aucuge was exploited. Radiocarbon dates for this point to the 5th century before our era, and straight finds of flat copper arrowheads have been made in Mali and in southeastern Algeria. 118 Why was there no Bronze Age in sub-Saharan Africa, and why did ancient Egyptian civilization not use it more? The reasons are partly to do with the fact that the third millennium before our era, which was the time when metallurgy, writing, monumental building in stone, the use of the wheel and centralized government became firmly established in Egypt, was also the millennium of the final desiccation of the Sahara, when people were moving out of it and when it could no longer serve as an indirect link between Egypt and West Africa. The link was not re-established until it was achieved with the help of the camel, some 3,000 years later. Other reasons are connected with the later and slower build-up of an agricultural economy in West Africa, as described above. Some writers have sought to give dignity and luster to West African history by trying to show connections with ancient Egypt, to enable West Africa to bask in its reflected glory. 9. This does not seem necessary. 120. The early iron, the GE from about 400 before our era to about 700 of our era. Throughout the early part of the Iron Age there must have been many parts of West Africa which had no contacts with the outside, and in most cases such contacts as there were with the classical world were slender, sporadic and indirect. 121 Much has been made of Hanno's supposed voyage, but the account is probably a forgery. 22 Herodotus's account of the Carthaginians' silent trade for West African gold is almost certainly based on fact. 123 Indeed, there must have been some reason for contact with the outside world, since it was at the beginning of this period that a knowledge of iron. 117 G. Daniel, 1943. 118 R. Mani, 1951. R. Mani and J. Hollemans, 1957, N. Lambert, 1970, 1971. 119. J. O. Lucas, 1948, C. 8. Diop, 1955, I. 960, 1960 to B. 120. C. T. Shaw, 1964 8, page 24. 121. R. C. C. Law, 1967, J. Ferguson, 1969, R. Mani, 1970 B, pages 78 to 137. 122. G. C. Picard, 1971, R. Mani, 1970, 1971, pages 73 to 77. 123. Herodotus, 1964 EDN, Book IV, page 363. 628. The prehistory of West Africa. Reached West Africa. This was not just an importation of iron objects, but also of the knowledge of iron manufacture, which, since there was no previous knowledge of metallurgy at all, is most unlikely to have been an independent invention. 4 At Taraga, in central Nigeria, the number of iron smelting sites have been excavated with radiocarbon dates from the 5th to the 3rd century before our era. 125 excavations in occupation mounds in the valley of the Niger also indicate the presence of iron by the 2nd century before our era. 6 It seems most probable on present evidence that the knowledge of iron metallurgy reached West Africa, not from Meroe as has often been proposed. 127 But from the area of Carthaginian influence in North Africa, perhaps with the chariot using Theramantes as the intermediaries. There are rock engravings of chariots along the route connecting the Pheasant to the Middle Niger Bend. 128 Another chariot route is revealed by rock paintings farther west, connecting Morocco and southern Mauritania, and perhaps it was the pressure of iron using nomads with the iron-pointed spear replacing the bow as the weapon most often depicted in the rock engravings which induced the late Stone Age inhabitants of Tchangier phase to fortify their villages from about the 5th/4th centuries before our era. 129 The He finds at Taraga were associated with terracotta figurines of the distinctive artistic style named after the Nigerian village of Nok where they were first discovered, as most of them have been. In the course of tin mining. 130 Since they come from tin-bearing alluvial deposits, it is often only the more solid and resistant heads of whole figures which remain intact. It was difficult at first to know whether the other artifacts found in the gravels were all contemporaneous with the figurines or whether they represented a mixture of contemporaneous and older objects. For in addition to iron objects and iron smelting draft pipes, there were ground stone axes and smaller artifacts of late Stone Age character. I-31 at NOW seems that the Stone Age material is older and represents an alluvial admixture. 132 At Taraga at any rate there was no Stone Age material, although at one of the rare Nok occupation sites, the ground stone axe was also found. 133 The Nok gravels produced dates which bracket the figurines between 500 before our era and 200 of our era. The time span subsequently confirmed and made more precise by the Taraga radiocarbon dates by one from the occupation site. 124. O. Davies, 1966 B, C. T. Shaw, 1969 c. pages 227 to 8. 125. B. E. B. Fag, 1968, 1969. 126. 8. J. Pretty, 1970. D. D. Hartle, 1970. F. Yamasaki et al., 1973, pages 231 to 2. 127. G. Clark, 1969, page 201. 128. R. Mani, 1950 to 8. H. L. Hope, 1966. C. T. Shaw, 1969 c. page 229. C. Daniels, 1970, pages 43 to 4. P. Howard, 1966. 129. R. Mani, 1947, 1971, page 70. P. J. Munson, 1968, page 10. 130. B. E. B. Fag, 1945, 1956 b. 1959. 131. B. E. B. Fag, 1956 b. 132. C. T. Shaw, 1963, page 455. 133. 8. Fag, 1972 b. 629. Methodology and African prehistory. Referred to 3rd century before our era and by a thermoluminescent date 620 plus 230 before our era. 134. The style of the NOK terracottas, although not uniform, represents remarkable artistic achievement, and some art historians have seen in them the ancestry of certain forms of the Yoruba art of 1,000 years later and 640 kilometers away to the southwest. 3-5 NOK finds have been made in an elongated area some 480 kilometers long to the south and west of the Jos Plateau. In an area around the Middle Gambia River in Senegal and the Gambia there is a district where there are large numbers of dressed stone pillars, isolated or arranged in circles. The most elaborate stones are double and resemble a lyre in shape. Excavations have been carried out which produced 3 radiocarbon dates in the 7th-8th centuries and which suggested that they were funerary monuments. Tests on the old ground surface below one of the monuments give 2 dates in the 1st century before our era, and this provides a terminus post-quart for its erection. 136. The remarkable collection of falliform stone monuments at Tonda Daru, in the Middle Niger Bend area, was plundered by the ignorant enthusiasm of 20th century diggers and administrators, with the result that we have little real knowledge of them. They may belong to the same period as the Senegambian monuments. 137. By the end of the early Iron Age, along the northern margin of West Africa, Negroid people were in contact with the nomadic Berbers of the desert who were now equipped with camels and carried West African gold north across the desert. By the end of the 8th century the fame of Ghana, the land of gold, had reached Baghdad. 138. These northern areas of West Africa were by now equipped with an agriculture and an iron technology, and were ready to embark on political development and the formation of states, to face the pressure from the northern nomads and to secure profitable control of the gold trade. Farther south, in northern Sierra Leone, the change to the use of iron does not appear to begin until the 8th century, and then not to have been abrupt. 139. 134. B. E. B. Fag and S. J. Fleming, 1970. 135. W. Fag and F. Willett, I. 960, page 32. F. Willett, I. 960, page 245, 1967, pages 119 to 20, 184, 1968, page 33. 8. Rubin, 1970. 136. P. Ohan, 1966. F. C. Bale, 1966. K. Sis and G. Philmans, 1968. P.M. Fagan, 1969, page 150. G. Descamps, 1971. 137. 8. M. L. Desplagnes, 1907a, pages 40 to 1, E. Moss, 1924, Armani, 1961, pages 129 to 34, 1971a, pages 133 to 6, 138, N. Levsey and 1971, page 120, 139, J. H. Gatherton, 1972, 1973, 630, Plate 24.1 Industry of Cape Manuel, Senegal Photo Idian U, Musée de l'IFN. $I. Plate 24.2 Stone pendants basalt from the Neolithic site at Pathboy Photo Idian U, Musée de l'IFN. Plate 24.3 Neolithic Bel Air pottery from the Diakite site, Senegal Photo Idian U, Musée de l'IFN. Plate 24.4 Pottery of Cape Manuel, Senegal, decorated fragments Photo Idian U, Musée de l'IFN.